So that is the general form of the transformation of any graph, right? Any function can be transformed using this general form. Okay, so if you notice, the main thing to notice here is that a is out here, outside of the function most of the time, and it is a multiplication operation right here. I am multiplying a times my function. Okay, b is inside of my function, and it's always a ratio, a fraction, 1 over b. Okay, h always goes with x every single time. Okay, h is always near x. It's either added or subtracted right here inside of the parentheses with x. So if you don't see anything being added or subtracted to x, then that means there is no h. H is 0. And k, on its lonely self, is always kicked out here at the end, right? Added at the end, or if k happens to be negative, then you will see minus whatever that number is. Okay. Now, using that general form, we can finally answer our questions. Okay. So the first question says, write the rule for g of x using the change describe. Okay, so what is going to be g of x in this case? It's going to be g of x is equal to, and now let's look at the change. It says a reflection across the y-axis. Which parameter is that? Reflection across the y-axis. Well, it's either b or a, right? Because that's a reflection. But if we're going across the y-axis, that means it's a horizontal reflection. Think about it. You're jumping over the y-axis. Here's the y-axis. Here's your graph. And you're going to reflect it over to this side like that. Okay? So that means that you're jumping over the y-axis. Okay? That's a horizontal reflection, which means that you have a b. Okay? B is negative in this case. Negative. And then followed by a vertical shift, it says, of 3 units up. Okay, so a vertical shift of 3 units up, that's k, right? Vertical shift of 3 units up. So all we have in this particular situation is b and k. We don't have h or a, which means we don't have to worry about this part, and we don't have to worry about this part. So this is what it's going to look like then. It's going to be f of, I'm skipping the a because it doesn't have an a, right? We don't have to worry about that. 1 over b. Okay, and in this case, it doesn't say about anything about any stretch or compression, so that means that b is 1, which means that there's a negative 1 right here. B is negative 1, because there is no stretch or compression. Let me zoom in and fix this. Okay, there is no horizontal shift, which means that there is no x minus h part, so all we have is x. But then we do have a shift of 3 units up, and k is always here at the end, plus 3. Okay, now you can rewrite that and clean it up and write it neater as f of 1 over negative 1 is simply negative 1, so negative x plus 3. Done. That is your g of x. As we go through the 4, hopefully all of your doubts will be answered. You will see more and you'll manage to work through all of them. Okay, let's look at 24 then, using the same steps. It says g of x, it says horizontal stretch by a factor of 5. Horizontal stretch by a factor of 5. Once again, horizontal stretch, that's b again. Okay. So horizontal stretch by a factor of 5, followed by a horizontal shift, again, horizontal, but now it's a shift or a translation, so that's h. So we have a b and an h, right, 2 units. That's all we have. We have no a or k. Okay, so it's going to look like this. Horizontal stretch, so it's going to be f of 1 over, remember b is always in the denominator, 1 over b. In this case, b happens to be 5, because it says horizontal stretch, so b is 5. And h is a shift to the right 2 units, which means that h is 2. So the rule is always x minus h, so it's going to be x minus 2. Close the parentheses, and you're done. No k, so there's nothing to add out here. No a, so there's nothing to write down here. That's it for that one. All right. So now that you saw those two, hopefully you can get it a little better. We can move a little faster. 25, a vertical compression, that is A, not B, because it's vertical, not horizontal. vertical compression by a factor of 1/8, followed by a vertical shift down 6 units. Vertical shift, that's K. And since it's going down, that means negative. So minus 6 is K, negative 6. And A is 1/8. So it would look like this. F of x is, no, not f of x, we're writing g of x, right? In terms of f of x. G of x. So there's a little confusion on that. F of x is our original function, and the transformed function is g of x. So we're actually writing g of x in terms of our original function, which was f of x. Okay, so it's going to be g of x is equal to, we have a, which is 1/8. A is always in front, times f of, there is no b and no h, which means that there's nothing in here with x, just x by itself. And there's k of negative 6, so minus 6 at the end. There it is. All right, 26, last one in this section. Why don't you try that one on your own? See how you can write it down on your own. Go back and watch the previous 3 examples if you need to see them again, or if you need to see the formula right here. Okay, so go ahead and try them on your own. Number 26, and pause the video right now and then come back in about 5 seconds. I'll show you guys the correct answer. Go ahead and pause the video now. Okay, so here's look at 26. This is the correct solution. G of x is equal to negative 2 times f of x plus 7 minus 5. How did I get negative 2 right here? It tells me that there's a reflection across the x-axis. Since I'm jumping over the x-axis, that means a vertical reflection, right? So that's A. A is negative. That's what it's telling me. Vertical stretch, that's still A by a factor of 2. So A is negative and it's a stretch of 2. So negative 2 for A. Then a horizontal shift 7 units left. That's H. H is negative 7. But when I put it in here, since it's x minus h, it's going to be x minus negative 7. So it's x plus 7. No b, notice that I don't have any 1 over something because there is no horizontal stretch or reflection or compression. And then a vertical shift 5 units down, that's k. K is negative 5. And that is your correct answer. All right, number 27 and 28 are the same type of question. It says find the inverse of each function, then graph the function and its inverse. Okay, so I'm going to go ahead and do 27, and I think I'm going to leave 28 to you guys to do on your own. Just watch as I do 27, and then you will be able to handle 28 on your own. So here we go. F of x is equal to 5x plus 10, and I'm looking for the inverse. Step 1, change f of x to y. Makes it easy to work with. Okay. Step 2, and this is where we can go 2 different routes. Some people prefer to change, reverse the x and the y right now. Some people prefer to solve for x first and then reverse the x and the y. Okay, either way you're going to end up at the same place. Okay, I'm going to go ahead and solve for x right now by subtracting 10 from both sides. And I get y minus 10 is equal to 5x. And I'm going to divide by 5. And I get x equals y minus 10 all over 5, which is the same thing as 1 over 5y minus 2. 10 over 5 is 2, right? Either way that you write it is actually correct. Okay? And then final step is to reverse the x and the y. I haven't done that yet, so I'm going to go ahead and do that right now. So it's actually going to look like this. I'm going to write it up here. Y is equal to, now that y that I just wrote is this x, right? I just changed the x to the y, and I'm going to change the y to an x. Y is equal to, I am going to write it in this form because it's easier for graphing. Okay? So y is equal to 1 over 5 x minus 2. That's your inverse. So I'm going to write it right here. And the final step is to change y to f inverse, right? F inverse of x. So it's already set up for me right here. I'm just going to go ahead and write the expression 1 over 5x right there, minus 2. There you go. And now it says graph both the function and the inverse. Okay, so I'm going to go ahead and graph both. I'm going to erase the work because the graph seems to be not complete, so I'm going to need that space right there. And this is the beauty about making videos. If you guys did not want me to erase that work, you can always just rewind it and see that again, right? And just pause it right there so you can work on it. Okay, so now I'm going to graph them both. I'm going to graph the first one, number 20, the original function. I'm going to do that one in black, and I'm going to do the inverse in blue. Okay, so 5x plus 10 means I will begin at 10. That's my y-intercept up there. And my slope is 5, which means I go up 5 over 1, but I can't go any further up because my graph ran out of space. So instead I'm going to go down 5. 1, 2, 3, 4, 5 over 1 right here. And I'm going to keep making points 1, 2, 3, 4, 5 over 1 and so on. And there's my graph. That's my original function they gave me. The inverse is telling me to begin at -2, approximately down here. My graph is cut off, but -2 is approximately right there. And then the slope is 1 over 5, so go up 1 over 5. And then draw your graph. Okay? And there is another way that you can come up with the graph, right? I did show you guys in class, those of you who are in my class, I did show you guys how you can come up with the graph sometimes in an easier way, okay? What you can do sometimes, no, not sometimes, all the time, is make a table of values for your original function, like this. Now let's do it in black to keep it consistent. Make a table of values for your original function. So just choose some values of x, -1, 0, and 1, for example. Substitute them into your function and see what you get. Plug in -1 into f of x, and I'm going to get -5 plus 10, which is 5. 0 plus 10 is 10, and 1 times 5 is 5 plus 10 is 15. I get those values. And then you want to write the inverse. All you got to do is, once again, let's do it in the color that matches to keep it consistent. Okay, so this is the inverse, just so you guys know. And this is the original function. If you want to just come up with the inverse, all you have to do is reverse the values. The first one is 5, -1. Second one is 10, 0. And the last one is 15, 1. Plot those points, and you will have the graph of both the original and the inverse. Okay, that's just another way of graphing it. To come up with the inverse function, you have to go through the steps that I just did. Okay, so at this point, I want you guys to go ahead and try number 28 on your own. Okay, so try it first. Once you have something that you think is correct, go ahead and watch my solution. I'm going to show you guys a solution right now. So go ahead and pause the video right now and try it. Okay, so here is the correct solution for number 28. Okay, the inverse is -x plus 10 over 4, all over 4. Or you could write it as -1 over 4x, right? I get -1 over 4 from right here. -x over 4, -1 over 4. Plus 5 halves, which is 10/4. Just simplified down, right? And then here's your graph. This is the graph of the original function. You begin at 10. Now it didn't fit right here on my graph. It's way up there, okay? But it does start at 10 and then go down, down 1 over 4. No, sorry, down 4 over 1, not down 1 over 4. And so it keeps going down 4 over 1, 4 over 1, and so on. Okay. The inverse is this one right here. This one you begin at 5 halves, which is approximately 2.5. No, it's exactly 2.5, sorry. Right here. And then you go down 1 over 4, down 1 over 4, and so on. Okay, so you end up at these 2 points right here. 6, 1, and 2, 2. They actually intersect at exactly 2, 2. Okay, let's continue. 29 and 30 are related to each other, so we'll do the same thing again. I'll do 29 and then I'll let you guys work on number 30 on your own. It says, write the equation of the cubic function whose graph is shown. In order to solve this, you need to figure out the standard form of a cubic function. Okay, so let me write it down for you guys. The cubic function, the standard form will always look like this. F of x is equal to a, and then in parentheses, 1 over b x minus h cubed, because it's a cubic function, plus k. Should look very familiar because most of the functions, now all of the functions we've been looking at always look something like this, right? There's 1 over b, there is a, there's x minus h, and then there's always k by its lonely self kicked out at the end, right? In this case, they are telling us that the graph is shown right here. It looks like on number 29 they gave us 3 points. That's perfect, okay? The most important point is that central point, that center point of your cubic function. Okay, if you guys can see it and if it's given to you, that is your best friend right there. Okay, that point in this case is 0, 2. That is the important point here. Just as in this one, the important point will be 3, 1. That point is important because it basically gives me what h and k are. Okay, h is 0 and k is 2. It has already given me those values. Okay. And then if we look at our function here, most of the time we are going to completely ignore 1 over b and just worry about a, okay, because they can actually be combined together into one parameter. So we're just going to worry about a, which means that I can erase this part right here and make my life a little bit easier. Like that. Okay, so now using that, I can pretty much solve my problem here. What I'm going to do is substitute in 0 for h, 2 for k, and remember where I got those from? From right here. I'm going to pick one of the other 2 points, doesn't matter which one, just pick the one you like the best. I like 1, 1. And I'm going to call that point xy. Okay, so that means that x is 1 and y is 1. Substitute in all of these values here, all of them, into my general form of my function, and I will solve for a. The only parameter that I don't know is a, right? That's the only one missing, so I'm going to solve for that one, okay? Now, in order to solve, I'm going to change f of x to y, right? Because I have y equals 1, so that'll be y right there, and then I'll substitute in everything else. So it's going to look like this. Oops, let me make it black. Like that. Now I just substitute all the values. Okay, so here we go. For y, I am going to put in 1. For a, nothing, just a, because I don't know what it is. For h, 0, so that I don't have to write x minus 0. Oh, I forgot about x. Let's go back. For x, I am going to put in 1. For h, once again 0, so I don't have to write 1 minus 0, just 1 cubed. And for k, 2. And I'm going to solve this simple equation for a. 1 cubed is simply 1. 1 times a, this is 1, times a is just a. So what I have is 1 equals a plus 2. Solve for a by subtracting 2. And I'm going to get negative 1 equals a. That was my missing parameter, and now I can write my general form. To make space, once again, I will erase. And my general form will look like this. F of x, or y, it's fine if you leave it as y actually, okay, equals negative 1. Where did I get that from? That's a. Times x minus h. Since h is 0, I don't care about x minus h. It's just x cubed plus 2. And you can actually get rid of those parentheses around the x and just call it negative x cubed plus 3 and you're done. Okay, but that's fine. I'll leave it like this. This is your solution. Okay, so I'm going to let you guys try number 30. Okay, so go ahead and try it right now. Pause the video, try it on your own, and then come back to see the answer. Okay, but try it on your own first. Okay, so here is your correct solution for number 30. The first thing you found was h and k. Okay, that's central point of your graph, 3, 1. So h is 3, k is 1. X and y, I chose 2.50, but you could have chosen 3.52. Okay, so I chose those. I substituted all of those into my general form, which, just to recall, looks like this. F of x is equal to a, I'm not using b, so it's just going to be a, times x minus h cubed plus k. Substitute in all those values into my general form, replacing f of x with y, of course. So let's just write y. And solved for a, end up with a equals 8. And so that's my function right there. 8 times the quantity x minus 3 cubed plus 1. Alright, let's work on number 31. It says graph the function, state the end behavior, the x-intercepts and intervals where the function is above or below the x-axis. So first, in order to graph the function, I am first going to find the end behavior and the x-intercepts. Okay, those are my most important things that I need to find in order to graph this function. Okay, so to find the end behavior, I have this very simple table that I use. The end behavior basically depends on the sign of a. Right, a could be positive or negative, and a is that initial value when it's written in standard form. Right, in standard form, this function would be ax cubed, because if you look at it, it's x times x times x, ax cubed plus something x squared plus something x, and so on. Right, a is that leading coefficient in front of my function that is attached to the x cubed, that is next to the x cubed. That coefficient is a. That's what I mean when I say a. And it's also determined, the end behavior again, is determined by the sign of a and by n. But an n, we don't care about the sign. It's always going to be positive. N, we care about if it's even or odd. Okay. And what is n? N is the exponent, okay, of my leading term. N is, in this case, 3, because it's x times x times x. So n could be 3, 4, it could be 2. And my end behavior will be based on whatever n is and whatever the sign of a is. Okay, and my table always looks like this. Okay, it's actually really easy to come up with this table. If a is positive, your end behavior is always going to be up. No matter what, your graph will increase at the end. It will keep going up. If a is negative, at the end, this graph will go down. So as x approaches positive infinity, the graph will go up if a is positive. If a is negative, the graph will go down as x approaches positive infinity. Okay, so basically towards the right, the graph will go up or down depending on the sign. Okay, and then another thing that you can fill out really quickly is when you see even, that means that the end behavior will repeat. Okay, if it's going up that way, then it's going up at the beginning as well. It's going to be up and up. And therefore, for a negative, it's going to be down and down because n is even. And for n odd, they're going to be opposites, right? If it's going up on one side, then it's going down on the other side. And if it's going down on one side, then it's going up on the other side. So that one's going to be down and up, and this one's going to be up and down. And that's how easily you can come up with that table. Okay, so practice coming up with that table, and it'll help you a lot with the end behavior. So in this case, we have ax cubed, okay? So it's not written in standard form. But if I multiply the first terms of every single one of these factors, x times x times x, I get x cubed. Simply x cubed, right? So the leading coefficient here that we're not writing is basically, it's 1. It's 1x cubed. So that means that a is 1. Is that positive or negative? So you should say positive, right? Is n even or odd? It's odd because it's 3. So a positive, n odd. My end behavior is going to be down and up. Down on this side, up on that side. That's what we mean by down and up. Okay, as x goes further to the left, it goes down. As x goes further to the right, it goes up. Okay, so the end behavior is down and up. However, we're going to write it in the correct notation. Okay, what we say in this case is as x approaches, let's say negative infinity. What does that mean? As x goes towards the left, right? As x approaches negative infinity, what happens to y? It also approaches negative infinity. As x goes more to the left, that's what I'm saying here. X goes more to the left, then y goes down. What happens towards the right? As x approaches positive infinity, that means to the right, what happens to y? Y approaches also positive infinity. Again, reinterpret this as x moves to the right, y moves up. Okay. X-intercepts, those are easy to find. Everybody should be able to see those just by looking at the function. X plus 2, what is the 0 that x plus 2 gives you? Negative 2. That's your x-intercept, right? 100% of students in my class should come up with that correctly without even trying. That's an easy answer to get. Okay. X minus 3 gives me positive 3 as my x-intercept. And x minus 1 gives you positive 1. Okay, so done with that. And then the final question is a question that you don't get asked much, but says, determine the intervals where the function is above or below the x-axis. Okay, so it's asking you, when is the graph above the x-axis? The x-axis. And when is the graph below the x-axis? In order to come up with those answers, I actually have to draw a rough sketch of the graph. Okay, and I have enough information to draw my sketch. Since they gave me, since I found the x-intercepts, which are negative 2, 3, and 1, okay, that's enough for me to draw a rough sketch of the graph. Okay, and I know that it's negative infinity, I mean it's down up here and up over here. Then I can connect these dots and cross the graph through those x-intercepts. The graph has to cross through this and only through those points. It cannot cross anywhere else. Okay, don't draw something weird like this and then cross through. It cannot cross anywhere else but those points, negative 2, 1, and 3. So if it's starting down here, it's going to cross through that one, then it's going to cross again through that one, and then it's going to cross again through that one, and then it's going to keep going up forever. And that's a rough sketch, very rough sketch of my graph, right? It's not perfect. But now I can see where the graph is above the x-axis. It's above the x-axis right here in this little bump, and from this point on, it's always going to be above the x-axis. So how do we symbolize it? I'm going to symbolize it using inequalities. It's above the x-axis from negative 2, as long as negative 2 is less than x and x is less than 1, it's going to be above the x-axis. Also, from positive 3 on, so as long as x is greater than positive 3, it'll be above the x-axis. Okay, I'm not including equals, because if I put equals, then it's right on the x-axis. I don't want it on the x-axis, I want it above the x-axis. So between negative 2 and 1, and after 3. Below the x-axis, using the same notation, below the x-axis is right here in this point, so between positive 1 and 3, and from negative 2 all the way to the left of that. Okay, so 2 parts. Positive 1 is less than x is less than 3, right? Between 1 and 3. And also when x is less than negative 2. Anywhere before negative 2, the graph will be below the x-axis. Okay, number 32 and 33, you should all be able to handle on your own, so I'll just let you guys work on it, and then I'll show you the answers in a little bit. Okay, so pause the video, do them on your own, and then unpause it so you can see the correct answers. Okay, here you go. These are the correct solutions for number 32 and 33. Go ahead and check your answers. These should not have been challenging, right? Just make sure you always write your answer in standard form. So I did put them in standard form here, in decreasing order for the exponents, for the degrees. Okay, let's continue with number 34 and 35, where we have to find the product. So basically it's a multiplication of polynomials. There's a few different methods that you can use to multiply polynomials. Okay, one of them is simply just to distribute, right? Just multiply this one times this one, and then times that one, and that one times that one, and so on. Another method that you can use is to use a box, right? A box method that many of you guys are familiar with. So for example, you would multiply p plus q, you would put p plus q on this side, and then you would put 4p squared, and negative p and negative 8q squared and then negative q here, and then you would fill in all the boxes to multiply. Okay, that's another way that you could do it. You could also use vertical multiplication, where it works the exact same way as regular vertical multiplication, right? When you multiply 23 times 467, for example, you stack them up like that, and you multiply the 3 times the 7, and then times the 6, and then times the 4, and you write them here, and then you write the 2 times the 7, the 2 times the 6, the 2 times the 4, and so on. It works the exact same way. You would put the p plus q down here. You would put the 4p squared minus p minus 8q squared minus q up there, and then you would do the exact same thing you do with regular multiplication. Q times q, q times 8q squared, q times p, q times 4p, and so on. Write them here, and then p times that one, p times that one, p times that one, and so on, and then you would add the two remaining parts. Okay, whichever method you choose, you should end up with the same answer. I'm going to go ahead and just do the distribution method because it's the method that most students use. However, you can use any of the other methods that you want. Okay, so here we go. Distributing simply means that I'm going to take p right here and multiply it times all of the terms in the other polynomial. Okay, so p times 4p squared will give me 4p cubed, and then p times negative p will give me negative p squared, and then p times negative 8q squared will give me negative 8pq squared. And finally, p times q will give me negative pq. And I'm done with p. And next you multiply q, and you do the exact same thing. Okay, multiply q times that one, then times that one, then times that one, and so on. Okay, you do the exact same thing you did with p. So q times 4p squared will be positive 4p squared q. Right? Make sure you notice where you put the exponent. The exponent goes with p, not with q in this case. Okay, whereas over here the exponent goes with q, not with p. Okay, and then the next one is q times negative p is going to be negative pq. And this one looks like it's going to extend over to this side over here. That's okay. Q times the next one, negative 8q squared, will give me negative 8q cubed. And it's starting to sound like a tongue twister. And finally, q times negative q will give you negative q squared. All right. Try to combine any like terms you might see. If you see any, if not, then you're basically will be done at this point. Okay, so let me see if I identify any. 4p cubed, I don't see any other p cubed. I see an 8q cubed, but not a p, right? Negative p squared, I do not see any p squareds by themselves, so no. 8pq squared, this one's similar, it's 4p squared q, but they're not the same because this one p squared and this one has q squared. Oh, there you go, negative pq and negative pq, those are like terms. Okay, they don't cancel, they're both negative, so we're going to put them together to make negative 2pq. Right, this one and this one will make negative 2pq. And that's it, there are no other like terms. Okay, so my final solution will be, let's write it in red, 4p cubed minus p squared minus 8pq squared minus 2pq, that's the one from here, plus 4p squared q minus 8q cubed minus q squared. And that's your final answer. Okay, so I'll let you try number 35 on your own. Go ahead and try it on your own first, and then pause the video. And once you're done, come back and check the final answer. Okay, pause the video now. Okay, so here's the answer for number 35. It might be in a different order depending on how you multiplied it. I went this way. I started with y squared because this one only has two terms, so I'm basically multiplying these two times those three. I went y squared times that one, times that one, times that one, and then 3x times that one, times that one, times that one. And that is my final solution. There were no like terms to combine on this one. All right, 36 is about using expressions to simplify some real-world problems. It says Kevin lives on a city block that has a perimeter of W minus 2 miles. Each day he runs around. You know what, before I continue reading, I'm going to draw the block. There's a city block, and the perimeter, they tell us, is W minus 2. So we don't know how long each side is, but I know that the total perimeter after they added up all the sides is W minus 2. Each day he runs around the block 3 times and then runs to the high school, which is an additional 2 miles. How many miles does Kevin run in 2 days? Oh, okay, so that shouldn't be that complicated. So if the perimeter is W minus 2 and he runs around the block 3 times, that means that in those 3 laps, he does 3 times W minus 2 miles. Right? 3 laps around the block, each block is W minus 2, so 3 times W minus 2. And then after he runs those 3, he continues running to the school, which is an additional 2 miles, so add 2 to that. He doesn't do that 3 times, he just does it that 1 time. And then the question is, how many miles will Kevin run in D days? So this right here that I just wrote is 1 day. In 1 day, 3 laps around the block, plus 2 miles to the school. So if we change the number of days to D, all you got to do is multiply the number of days times the expression. And so in however many days he runs, D, he can multiply that times however many miles he runs per day, and that'll be his total. There you go. That is the total expression right there. I'm assuming the problem probably wants you to expand it as much as you can. So let's go ahead and do that and not leave it in this form. Okay, so here we go. Let me erase this part so I can do my work. So inside of the parentheses, the first thing I'm going to do is distribute the 3 right there and right there. So that's going to give me 3W minus 6 plus 2 times D, like that. Right, notice that there's parentheses around the 3W minus 6, and then there's another parentheses around the 3W minus 6 plus 2. Next, I am going to combine the 3W minus 6 plus 2 because negative 6 and positive 2 make negative 4. So I get this. Right, I basically just took out 3W minus 6 out of the parentheses and added 2 to it. And now I'm going to distribute the D into these parentheses here. So it's going to be 3DW, or WD, doesn't matter, minus 4D. And that is your final answer. He runs 3WD minus 4D miles in D days. Alright, moving on to 37, 38, and 39, using the binomial theorem to expand a binomial. Most of you guys are pretty good at these types of problems. So I'll do 37, and then I'll let you guys work on 38, 39 on your own. Okay, so here we go. Let's work on 37. The first thing I need for 37 is to have Pascal's triangle handy. So I'm going to go ahead and write it out right here. 37 only wants me to go up to row 4. But you're going to need it all the way up to row 5 for number 39. So I'm going to go ahead and write it all the way up to row 5. Okay, Pascal's triangle. 99% of you guys are pretty good at coming up with Pascal's triangle on your own. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Stop. I don't need any more rows after that. Okay, if you needed more rows, like row 6 or 7, you could keep going. But I'm here at row 5 already. How do you know this is row 5? The second term tells you, right? That's row 5, row 4, row 3, row 2. This is row 1. That single 1 at the top is row 0. Okay, so using those values, I am looking at 37. I need row 4. right? 1, 4, 6, 4, 1. So I'm going to write out those values. Those are my coefficients. 1, parentheses, parentheses, plus 4, parentheses, parentheses, plus 6, parentheses, parentheses, plus 4, parentheses, parentheses, plus 1. I'm going to have to erase Pascal's triangle, so you can go ahead and write it on your own paper, so you guys always have that handy, okay? And my last term is 1, parentheses, parentheses. All right, this is all coming back to you guys. Next thing, before I start plugging in stuff, I write out the exponents. Always write out the exponents just so you're clear on how you're supposed to go. Okay, the very first parentheses on the very first term is 4. Where did that 4 come from? From right here. It's always whatever that exponent is, it's the very first one you use. Okay, and then you could go the way of writing in the exponent here, but usually we just go 4 and then go to the next one and write 3 on this one, 2 on this one, 1 on this one, 0 on this one, right? It always goes on descending order. 4, 3, 2, 1, 0. Notice that I'm putting those exponents on the first parentheses only. For the second parentheses, it goes the opposite way, right? It starts at 0, and then it goes up 1, 2, 3, 4. And now finally I am going to plug in my values, right? My 2x and my y. So the first parenthesis is 2x, the second parenthesis is y. Okay, so here we go. 2x, y. 2x, y. 2x, y. 2x, y, and 2x, y. And then finally, the final step is to just clean that up, right? Simplify it all the way down to its simplest form, okay? And that's where the mistakes might happen. So make sure you're careful and you take your work carefully here. Take it slowly so you don't mess up, okay? So on the very first one, I'm looking at this one right here. Y to the 0 is nothing. That just cancels out. Kick it out. The 1 is truly unnecessary also. Right? So all you really have is 2x to the 4th power. So remember, when you have to the 4th any power outside of parentheses, you need to use it on any of the terms inside. So it's going to be 2 to the 4th, x to the 4th. Okay? 2 to the 4th power is 16. So it's 16x to the 4th. All right? I'm looking at the second term here, and what I have is y to the 1 power. So that's just y. And then I have 2 to the 3rd power, x to the 3rd power. Okay, 2 to the 3rd is just 8. But I'm going to multiply that 8 times this 4. So 4 times 8 is going to be 32. X to the 3rd, coming from here, and y to the 1 from that one, which is just y. There, done with that one. In the next one, I have y squared. I have x squared, I have 2 squared, which is 4, and I'm going to multiply times the 6 in front, so 6 times 4 is 24, and I x squared, y squared. In the next one, I have y cubed, x to the 1, which is just x, 2 to the 1, which is just 2, but I'm going to multiply times the 4 here, so it's 4 times 2, which is 8, so plus 8. X to the 1, y to the 3rd. And my final term, 1 is unnecessary. I can just cross that one out. 2x to the 0 power, that's just 1, right? So you can also cross that one out. And then y to the 4th, that's all you have left. So just y to the 4th. And there it is. That is the expansion of 2x plus y, the quantity 2x plus y, to the 4th power. Okay, so go ahead and try 38 and 39 on your own, please.
Here's what I found on the web for 4th power.
Try 38 and 39 on your own. And pause it right now, do it, work on your own, and come back and watch the correct solution once you're done. Go ahead and pause the video. Okay, so here's the correct solutions for number 38 and 39. Go ahead and check your answers. Make sure you multiplied everything correctly so that we can move on to 40 through 43. All right, let's move on to 40, 41, 42, and 43. These are pretty challenging factoring problems. Well, maybe except for 41, which you can just do factoring by grouping, and if you're good at that, it should be pretty simple. Well, now that I look at it, 42 should be simple as well. Okay, and 43. Okay, well then maybe only 40 is the challenging one. You know what, let's leave that one till the end, and let's work on 41, 42, and 43, the theoretically easier ones. And then we'll work on 40, which is a little bit of a challenge if you don't see the pattern there. Okay, 41, I see 4 terms, I see a cubic, so my go-to method is always factoring by grouping. If factoring by grouping does not work, then I can try something like synthetic division to see if it's actually factorable. Okay, so let's try factoring by grouping. Hopefully it works. Right, I've grouped those two together. I'm also going to group these two together. Make sure you notice that when I am grouping these, I do not mean I'm going to multiply them, because that's what it seems to look like right here. Okay, but I'm just basically grouping them and writing them apart. So there should still be some kind of sign separating them right here, like a plus sign right there, right? So there's 2 separate terms. All I did was group the 2 terms on the left together and the 2 terms on the right together, okay? And I'm going to factor as much as I can to see if it's actually going to be a factorable polynomial. So let's see, on the 2 terms on the left, what do 24 and 56 have in common? What can I divide them both by? I'm thinking 8. Is 8 the largest number that goes into both of them? Yeah, right? 8. 8v squared is what they both have in common. So 8 goes into 24, 3v. And 56 divided by 8 is 7. And since I factored out v squared, then it's gone. There you go. The one on the left, I see that the 15 and the 35 have a 5 in common. But since the first term is negative, I'm going to factor out negative 5. And therefore, it's going to leave me with 3v plus 7. Perfect. It is factorable then. This should be good news right here. I see 3v plus 7 here, and I see 3v plus 7 here. That means it actually will be factorable because I have the same factor on both parts. Okay? And then after this point, you take 3v plus 7, which is your first factor. I know I'm continuing down here, which is nothing to do with that problem, right? So ignore that piece. I take 3v plus 7, which is the factor they have in common. And the other factor will be the 2 terms that I factored out at the beginning. Okay, so 8v squared and negative 5 go in here. 8v squared minus 5. Okay, keep trying to factor at this point. Don't stop. Okay, keep trying to see if there's anything else you can factor. For example, look at this and see if there's anything that you can factor out. Nothing, obviously, for that one. And in this one, same thing. This one is not factorable. Okay, I see v squared and I see a difference, but these are not perfect squares, so I can't factor that. So therefore, that's done. That is your final answer for that one. All right, let's move on to 42 then. And then 43, I'll remove that erasure that I made right there. 42, x to the 6th minus 64. First thing I notice here, I'm looking for patterns, right? Is that 64 is a perfect square. Okay, it's 8 squared. I also notice the minus sign. That's good for me. I want a difference of 2 perfect squares. Okay, but what you might not notice is that x to the 6 is also a perfect square. Okay, it is something squared. Okay, and you might not see it at first, but if you think of 6 as a factor, a multiple of 2, then you gotta figure out what is the number that I can multiply 2 times to get 6. You should come up with 3. So it's x cubed squared. Right? I just wrote it as the difference of 2 perfect squares, which means that I can use my special patterns. Okay, I'm gonna rewrite it over here. X cubed squared minus 8 squared. I can use my special pattern, which is the difference of 2 perfect squares, to write x cubed minus 8 and x cubed plus 8. Oh, I just noticed this one's going to be a fun one. Awesome. Some of you guys, if you're familiar with all of the patterns we have studied, should be looking at this one and thinking, wow, really? We're going to do all of this? Yes, we're going to do all of this, okay? And if you haven't seen it yet, don't worry, we're going to go through it together, okay? What am I talking about? This right here is a perfect cube, and this is a perfect cube. So I have the difference of two perfect cubes. That is one of the special patterns we have learned. We're going to factor that. This is a perfect cube, and this is a perfect cube. So we have the sum of two perfect cubes. That is a special pattern we have learned. So we're going to factor both of these out into something completely new. Okay, so here we go. So let's do it. Let's start with x cubed minus 8. Okay, I'm going to erase this one over here. I'm assuming you guys already copied down there and have the correct answer. So that I could use the entire space over here. Okay, so I'm starting with x cubed minus 8. Okay, I'll worry about this one later. I'm just going to worry about this one first. Okay, so what I see there is that I have a perfect cube and minus a perfect cube. So I'm going to use that special pattern that we learned, which goes like this. Okay. You're going to get a binomial and a trinomial. Right? That's why I left the second parenthesis larger than the first one. You're going to take the cube root of your first term. Okay, so what is the cube root of x cubed? X. The cube root of your second term, which is 8, so the cube root is 2. Right? 2 times 2 times 2 is 8. The sign here is going to be the exact same sign as the original problem. Okay, so it's going to be minus. In the second parentheses, which is going to be a trinomial, the very first term is this first term that you just wrote squared. It's always going to be squared for this one. Okay, so that's x squared. The last term is the second term you wrote over here, also squared. Okay, and that one is going to be always positive no matter what. So that one's 4. Positive always. The middle term, the one we're missing here in the middle, is going to be the product of these two terms, but it's going to be the opposite sign. Okay, so x times 2, which is 2x, and the sign will always be the opposite of what your original sign was. So if this was negative, then this one right here is going to be positive. And that's it for that one. That is this one right here. We just factored it out to this form. Okay, now x cubed plus 8, we're going to follow the exact same steps. I'll do that in different colors so it could stand out. So x cubed plus 8, once again, same thing. Binomial, trinomial. Cube root of the first term is x. Cube root of the second term is 2. And this one will be plus. Okay. The second term, the trinomial over here will be x squared. So remember how it goes. This one squared. This one squared will be the last term, so that's 4. The middle term will be the product of the 2. X times 2 is 2x, but again the sign will be the opposite. This was always positive. It's 2x, but it will be minus because that one was plus. Okay, and then you can try to factor even further, but in this case that's it. This is you're done. You cannot break this down any further than this. Okay, x minus 2 times x squared plus 2x plus 4 times x plus 2 times x squared minus 2x plus 4. That's as far as it gets. Alright, now let's look at number 43. We're going to look at it as the exact same way that we saw number 42. Okay, I see 9 is a perfect square, and I can also turn x to the 6th into a perfect square, and since it is minus the sign here, I can use the same pattern that I used at the beginning over here. Okay, so let's work on that one. It's going to be, I know 9 is 3 squared, so let's start with that. And I know x to the 6th can be turned into, as we saw before, x cubed squared, which means that I have 2 perfect squares right here. Okay, so I can come up with 2 sets of parentheses. In the first one, I put x cubed and 3. In the second one, I put x cubed and 3, 1 plus, 1 minus. Okay, And it looks like I'm done. There's nothing else to do here. Okay, x cubed plus 3. X cubed is a perfect cube, but 3 is not. And the second one, same thing. 3 is not a perfect cube. So there's nothing else to do here. You are finished. Alright, so let's look at number 40. Okay, this is the one that I left till the end because it was going to be the most challenging of the 4 that we're working on right now. So it says 3b to the 7th plus 12b to the 4th plus 12b. Okay, and I need to factor it and simplify as much as I can. Okay, so the first thing I notice is that all of them have a 3 in common and a b in common. So I can factor out 3b. You should be able to see that as well. When I factor out 3b from the first one, I get b to the 6th. In the middle term, I'm going to get 4b cubed. And in the final term, I get 4. Okay, so far so good. Everybody should be able to get to that part. Okay, the next part is the one that's going to be tricky. So be careful, pay very close attention to what I'm about to do here. At first glance, it looks like this trinomial is not factorable, that I can't do anything else. Okay, however, I do notice a very specific pattern that sometimes works out. Okay, and it's a kind of tricky pattern that you have to look out for. Okay, anytime you see a trinomial, 3 terms, where the first term, the leading coefficient, the first term and the middle term both have the same variable, and the exponent of that variable is exactly half of the first term, so 6 and 3, or 4 and 2, or I don't know, 10 and 5, any kind of pattern like that. And the last term has to be a single constant, no variables on it. Then you can use this special pattern that I'm going to show you right now. Okay, what we're going to do is a little bit of substitution. Okay, follow me along and you'll see. B cubed, I am going to replace every b cubed that I see with, just pick a variable that you want to use. Let's say x. So every time I see b cubed, I'm going to replace it with x. Okay, that's what we're gonna do. So let me write it down here so I could use that space right there. Every time I see b cubed, I'm going to replace it with x, and it'll become obvious once I do it. You'll see why I'm doing what I'm doing. Okay, and remember what I said. You can only use this special pattern if you see this special relationship right here. This is 6 and this is 3, or 4 and 2, or 10 and 5, right? Or 8 and 4. Any pattern where it's exactly this one's double of that one. So every time I see b cubed, I'm going to replace it with x. And look what happens. For now, I am going to ignore this 3b. I'm not going to use it or bother with it until the end. I got to remember that it has to be there as part of my solution. Okay, so 4b cubed becomes 4, just messed up, x. Right? Because I said every time I see b cubed, I'm going to replace it with x. And that single 4 at the end is just 4 because there's no b's or b cubes next to it. Okay, b to the 6th, if you think about it, b to the 6th, we've done this one, this similar one right here, we did x to the 6th, is the same thing as b cubed squared. Okay, and therefore I see a b cubed right there. I'm going to replace this with x, so it's actually going to be x squared. Okay, I'll repeat that, watch. B to the 6th is b cubed squared. And since I said that I'm going to replace every b cubed that I see with x, I can just replace it with x to become x squared. Okay, so this b to the 6th right here is simply x squared. Let me erase this work right here so I can continue working. And now it should seem pretty obvious why I did what I did. I can factor this. This is a factorable trinomial. Okay, I know how to factor this. I need to multiply a times c, okay, and then come up with the correct pair of factors that's going to work out. Okay, so let's do that. A is 1, c is 4, so a times c is 4. What two numbers do you multiply to make 4, but when you add them, they make 4? They add up to make 4. So when you multiply them, they make 4. That's from a times c. But when you add them, they make 4. That should be pretty obvious. 2 and 2, right? 2 times 2 makes 4, and 2 plus 2 is 4. Therefore, my two factors are x plus 2 and x plus 2. Everybody still following? Okay. And now that I'm done, I just factored it. That's it. There's nothing else to factor. Now what I'm going to do is replace that x with b cubed again, because it wasn't x, right? I just replaced it as a placeholder, but now I'm going to replace it back with b cubed. So I get b cubed plus 2 and b cubed plus 2. And 3b in front. Don't forget the 3b in front. And that's my final answer. It's been factored. That one's a little tricky. I suggest you rewind and rewatch how I did this problem from the beginning a couple of times so you can understand exactly how it happened. Alright, let's move on with number 44. It says Fatima has an herb garden. She grows parsley in a triangular section having an area of 1/2 times the quantity 3x squared minus 6x minus x plus 2 feet squared. What are the dimensions for the base and height of the parsley section? Okay, so she's got an herb garden. I'm going to draw that. And she grows parsley in a triangular section. There you go. That shows you how carefully I was reading. It says triangular section, not rectangular. So let me erase this rectangle here and draw a triangle instead. So in the triangular section, she is growing parsley. Okay, the area of this triangle is exactly what they wrote right here, right? 1/2 times 3x squared minus 6x minus x plus 2. And the question is, what are the base and the height of this triangle? Okay, so I'm going to use what they gave me, 1/2 3x squared minus 6x minus x plus 2, and the fact that I know the formula for the area of a triangle is 1/2 base times height, and compare them to each other. Okay, so basically I'm going to set it up like this. Let me erase the picture. I don't think it's necessary anymore. I have 1/2 times 3x squared minus 6x minus x is minus 7x, right, plus 2. That's the area of the triangle of her garden. And I'm going to make that equal to the formula, 1/2 base times height. And that will allow me to figure out what the base and the height is. Okay, so since I see 1/2 on both sides, I can multiply both sides times 2. And basically, both of those 1/2s will go away. So what I have is 3x squared minus 7x plus 2 is equal to the base times the height. And now my job is to figure out what is that base and what is that height. Right, that's the goal here. What is that base? What is that height? Okay, so what I'm going to do is I'm going to try to break down this trinomial into 2 factors, and one of them will be the base and the other one will be the height, simply by factoring. Okay, I'm just going to try to factor it out. So to factor it, I use A and C. Some of you guys are not familiar with this process. Some of you guys use X factor all the time, right? A is 3, C is 2, so A times C is 6. So then I think, what 2 numbers do I multiply to make 6? But when I combine them together, they make -7. Okay? And most of you guys should come up with those numbers pretty quickly, right? It's going to be -6 and -1. Multiply them, you get -6. Combine them, you get -7. I think I just misspoke. Multiply them, you get +6. Combine them, you get -7. So those are your 2 factors, right? -6, -1. So what you write is this. 3x squared minus 6x minus 1x plus 2. I think most of you guys are familiar with that process. You write the first term and then the 2 factors that you just found, okay, and put x with them, -6x, -1x. And then the final term. And then what you're going to do is you're going to factor by grouping, which we've done already, right? 3x squared minus 6x, the common factor is 3x, so it's x minus 2. For the second pair, I'm going to factor out -1. They really have nothing in common, but I don't want a negative. You never want a negative right there as the first term. So -1 is out, and so that leaves me with x minus 2. And I notice that I have the same factor in both, x minus 2, so that's your first factor. and the other one is 3x minus 1. And there it is. That is BH, which means that the base is x minus 2 and the height is 3x minus 1. Or vice versa, it doesn't really matter. It's just asking you what are the dimensions. One of these is the base, the other one is the height. Okay, and that's it. Alright, 45 and 46 are division problems. The instruction says to use long division or synthetic division, whichever one you want to use. So what I suggest for you guys is for 45, use long division, okay, because it says 2x plus 4. Synthetic division only works if the first term is simply x, like that one. And for 46, use synthetic division, okay? So if you're a little confused about that, I'm just going to get you guys started on what the correct way of setting it up is, but I'll let you guys finish it and then come back and check your answers, okay? So here, let me set up 45 for you. You're going to write 2x cubed plus 14x squared. Make sure you always write them in standard form. Minus 4x minus 48. Okay, and you're going to divide that by 2x plus 4. Okay, so you can do that on your own. Work it out, and then I'll show you the answer in a little bit. For 46, just to get you started, you're going to write 1, 12, 0, negative 4, right? Those are the coefficients of your terms. 1, 12. Where does 0 come from? From the missing x part, and negative 4. And you're going to divide that by not negative 3, positive 3. Remember what I've been saying in class? If you're dividing by x minus 3, you're trying to check really if 3 is a solution, right? X minus 3 equals 0 gives you x equals 3. So you're dividing by 3 in this case, okay? And then you're going to use synthetic division to finish that off, right? Bring down the 1 and so on. Okay, work it out on your own. See if you can come up with both answers, 45 and 46. Pause the video right now, do your work, and then come back and check the answers. Okay, pause video now. Okay, so here's the solution to 45. I know it might be a little bit difficult to see here. That's why I did it in red right here, and I'm highlighting your solution in red. I use a long division, so like I started it, 2x cubed plus 14x squared minus 4x minus 48 is inside, and 2x plus 4 is outside. You multiply times x squared, and you're going to get 2x cubed plus 4x squared right here. You subtract, you end up with 10x squared, bring down the negative 4x. Multiply 2x times 5x to make 10x squared, and you're going to get 10x squared plus 20x. Subtract, and you're going to end up with negative 24x. Bring down the negative 48. Multiply 2x times negative 12 to make negative 24x, and you're going to get negative 24x minus 48. You subtract that, and you get 0. Okay, so there's no remainder. The remainder is 0. So that's your solution. When you divide those two terms, you get two polynomials. You get x squared plus 5x minus 12. No remainder. 46, a little different. Here's the work for 46. I have 1, 12, 0, negative 4 like I started it. I'm dividing by 3. I'm putting 3 here, not negative 3. 3. Make sure you always check that for synthetic division. Bring down the 1. 3 times 1 is 3. 12 plus 3 is 15. 3 times 15 is 45. 0 plus 45 is 45. 3 times 45 is 135. Negative 4 135 is 131. Okay, and you're done. Notice that we didn't get 0, which means that x minus 3 doesn't actually go into it. So we have a remainder. Your solution should look like this. This one, the 1 right here, that's x squared. The 15 is 15x. And the 45 is by itself. And the remainder is 131. Okay? So what we do is we write remainder 131, but that looks awkward. We don't like writing that anymore. So what we say is we write x squared plus 15x plus 45 times x minus 3 plus the remainder is equal to my original polynomial, this one right here. Okay, but that's basically all you need to write. When you multiply x cubed x minus 3 times x squared plus 15x plus 45, you will get x cubed plus 12x squared minus 4. Okay, as long as you add the remainder 131 at the end. Okay, 47 says use synthetic substitution to evaluate p of x for the given value. You don't actually have to use synthetic substitution in this case. Okay, you can just substitute in -2 in here and see what you get. But synthetic substitution is a much faster method. Okay, so you will do this. You'll set it up for synthetic division. -3, 5, missing x squared, so I'm going to put a 0 there. -1 and 7. And I'm checking that -2 is a solution, is what you're really doing. Okay, you're checking what -2 is a solution. Whatever your remainder is, that's what the value is going to be. Bring down -3. -2 times -3 is positive 6. 5 and 6 makes 11. -2 times 11 is -22. 0 and -22 is -22. -2 times -22 is positive 44. -1 and 44 makes 43. And -2 times 43, right here, -2 times 43 is going to be -86. And -86 and 7 make -79. That's your answer right there. When you plug in -2 into this polynomial right here, and you can test that out yourself, plug in -2 right here, and right here, and see what you get. You will get, guaranteed, as long as we didn't make any mistakes, I hope we didn't, you will get -79. Okay, that's what we just did. So P of -2, meaning I substituted -2 into my polynomial, is -79. Okay, number 48 says use the factor theorem to verify that the given binomial is a factor of p of x, then divide. Okay, we're not going to use the factor theorem, then divide. We're going to do both things at the same time, okay, because while we're testing the factor theorem, we are dividing at the exact same time. Okay, so the factor theorem basically says that if I do synthetic division or long division with -5 for synthetic division or x plus 5 for long division, and I get a remainder of 0, then that means that this is a factor of that. Okay, and if it is a factor, then it makes it easy for me to break this down using synthetic division. So I'm going to use synthetic because it's much faster to work with. Okay, so here we go. Set up the 2x squared plus 6x minus 20 for synthetic division. 2, 6, -20. And I am dividing, I am testing -5. And the factor theorem basically says that if I get 0 here, then x plus 5 is a factor. Okay? Let's hope I actually do. So let me erase that. We don't know for sure yet. So here we go. Bring down the 2. -5 times 2 is -10. 6 and -10 makes -4. -5 and times -4 makes positive 20. -20 and positive 20 makes 0. There it is. So x plus 5 is a factor because I got remainder 0. What's the other factor? If x plus 5 is one of the factors, what's the other one? It's right here, right? This is the other factor, 2x minus 4. Oh, then now I understand why it says then divide, because we could still simplify this even further, right? 2x minus 4 becomes 2 times x minus 2. But I'm not going to leave that 2 there. I'm not going to leave that 2. I'm going to put it up here in the front. So my final solution is 2 times x plus 5 times x minus 2. There you go. It's been factored. All right, let's keep going. We're almost at the end here. Okay, we're starting with 49. From 49 to 55, it's all factoring, okay? So there's a bunch of different methods that we learn on how to factor, and we're going to try to work them all out here, okay? Remember that synthetic division, or long division if you guys prefer long division. I always seem to go for synthetic division, but synthetic division is basically your last resort most of the time, okay? You're going to always try to factor by grouping. It just makes it faster and easier if it is factorable by grouping. If that doesn't work, you're looking for those special patterns like a difference of two cubes, the sum of two cubes, the difference of two squares. Make sure you always take out the GCF. That should be the very first thing you do in all of the problems. And then if nothing else works, then start on synthetic division, where you're going to be testing out different factors. Okay, so here you go. Let's start with number 49. I'll probably do 49 and then I'll let you guys try out 50 and 51 on your own. Okay, so here we go, 49. So it says 4x cubed plus x squared minus 4x minus 1. I see a cubic equation and I see 4 terms. That gives me a clue that probably factoring by grouping might work. Not guaranteed, but it might work. So I'm going to try that as my first attempt. Okay, I already checked if there was a GCF and I skipped that part of my work, but every time you get one of these problems, check that you can't factor out a GCF, because if you can, take it out. It makes your problem much easier. Okay, so 4x cubed plus x squared, they have an x squared in common, leaving with 4x plus 1. On the second pair over here, again, I see a negative right here in front, so I'm going to factor out negative 1, leaving me with 4x plus 1. And there you go, look at that. For factoring by grouping is working because I see the exact same factor on both of them. So it's going to be 4x plus 1, I know that one. And the other factor comes from this one and this one, right? X squared minus 1 equals 0. X squared minus 1, you should have noticed this. If you didn't, look out for these other special patterns, right? This is a difference of two perfect squares. So I can factor this even more. Okay, so it's going to be 4x plus 1. And then x squared minus 1 breaks down into x plus 1 and x minus 1. Right? Because x squared is a perfect square, 1 is a perfect square. And there you go. That's going to give me my 3 zeros, my 3 solutions are. From this one I get 1, and from this one I get negative 1. So those are the first two. 1 and negative 1. And the last one you should be able to do in your head, but if you can't, remember, just set this equal to 0. 4x plus 1 equals 0 and solve that. So I'm going to continue here to solve it. Subtract 1 from both sides. You get 4x equals negative 1 and divide by 4. So you get negative 1/4. And that's it for that one. Okay. Go ahead and try 50 on your own. See how you do on this one. My hint to you guys on both of these is to make sure you take out the GCF right away. Okay, there is a GCF in both of them, in 50 and in 51. And the second hint I'll give you guys to help you guys out is on 51, you see that the first term is negative. We always like it if the first term is positive. It's going to make our job much easier. So when you factor out the GCF, factor out negative whatever the GCF is. Okay, so factor out negative something. That way you will turn this first term into positive, and then try to continue factoring after that. Okay, go ahead, go for it. Pause the video right now, and then come back to check your answers. Okay, here you go. These are the correct answers for number 50 and number 51. In 50, I factored out a GCF, which was 3x cubed. And then I got a quadratic, which was x squared plus 6x minus 7. Minus 7. Okay? And then you factor that out, and you get x plus 7 and x minus 1. And so your solutions are 0. That one comes from here, right? 3x cubed equals 0. After you solve that, divide by 3, you get 0. Take the cube root, you still get 0. Okay? The solution to that is 0. This one will give you negative 7, and this one will give you 1. And those are your 3 zeros. Your 3 solutions, right? Remember what we learned about the fundamental theorem? The fundamental theorem says that we should have 5 zeros, not just 3. Okay, so what happened to the missing 2? They're right here. Remember, this is 0 multiplicity 3, because it happens 3 times. In 51, you factor out negative x squared, like I said. So they have an x squared in common, but I made it negative x squared so I could make this one positive. And then with what's left, I factored it and I got x plus 2, x minus 4. And so my three zeros are 0 from this one, negative 2, and positive 4 from that one. And once again, I should have 4 zeros and I only have 3. That's because this one has a multiplicity of 2. Okay? All right, let's move on. Okay, so number 52 says, 52 and 53, the same instructions. Identify the rational zeros of the function, then write the function in factored form. Okay, just like in the previous ones, I'll do one and I'll leave the other one for you guys to work on. Okay, so we're going to find the rational zeros of this function. I'm trying to see if this is factorable by grouping. And no, it's not going to work. You can try, right? Set up the first two pairs and the second two, and factoring by grouping will not work. Okay, there's no other special pattern here, so we're going to have to use synthetic division to work it out. Okay, so 1, 3, 3, 1. And you're going to be testing out various numbers here. The good news is that this last term here is 1, which makes your job so much easier because you're just looking for factors of 1, and the only two possibilities are positive 1 and negative 1, and that's it, right? So let's start with 1. And if that doesn't work, we'll try negative 1. Bring down the 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. 3 plus 4 is 7. 1 times 7 is 7. I get 8. That doesn't work. I should get 0, right? If it actually works, I should get a 0. So let's make this negative 1, and let's erase all this work that we don't need, and do it again. Now 1 didn't work, negative 1 must work. If negative 1 doesn't work, then this is irreducible, right? We can't factor it. Bring down the 1. Negative 1 times 1 is negative 1. 3 minus 1 is 2. Negative 1 times 2 is negative 2. 3 minus 2 is 1. Negative 1 times 1 is negative 1. Negative 1 and positive 1 makes 0. There it is. Okay, so my first one is negative 1. And I have this leftover piece right here is a quadratic, right? I can write that as x squared plus 2x plus 1. And you can try to factor that even further. I don't think anything works. Oh yeah, you can. I lied. Now this negative 1 right here, it has a factor that goes with it, right? This is the 0, which is negative 1. What was the factor that gave you that 0? Not x minus 1, but x plus 1. Correct? And we're going to try to break this down even further by factoring. Since it's a quadratic, we know methods of factoring a quadratic. A times c is 1 times 1, which is 1. Two numbers that you multiply to make 1 and they add up to make 2. That should be pretty obvious. 1 and 1. 1 times 1 is 1, and 1 plus 1 is 2. Therefore, my factors are x plus 1 and x plus 1. For this one, the factors are x plus 1, x plus 1. And I already have an x plus 1 here. So really, the complete factored form is x plus 1 times x plus 1 times x plus 1. Which you can simply write as x plus 1 cubed. Okay. And maybe some of you guys had already seen that based on the coefficients here. 1, 3, 3, 1. That is the third row of Pascal's triangle. Okay. But if you didn't see it, that's fine. Just this is the purpose of this is to try synthetic division until you find the factors. All right, 53 is yours. I know I did the easier one. You guys do the more complicated one. Okay, 53 is yours. You're going to use synthetic division until you find the factors that work. Okay, and what are you going to test? You're going to test any and all factors of 48 that you know. Okay, so I'll list them out for you guys. You should come up with that on your own. But you're going to try plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and so on to get to 48. Okay, you only need to find one. As soon as you find the first one that works, you're pretty much done because you're going to have a quadratic, since this is a cubic, you're going to have a quadratic, and then just factor that quadratic using other methods, okay, like X factor for some of you guys, or factoring by grouping or some other method, but you can factor that quadratic much easier. You only need to find the one that works here. Okay, so go for it. Pause the video right now and try it on your own. Okay, so here's the correct solution for 53. Okay, I did synthetic division. 1 didn't work, -1 didn't work, 2 didn't work, -1, -2 didn't work, but 3 worked. When I tried 3, it did work. Therefore, that's where I got this x minus 3 from. Okay, what was left over is what was a 1, an 8, and a 16. So I turned that into a quadratic. I took this quadratic and I factored it. 1 times 16 is 16, so I came up with two numbers that multiplied to make 16 and add up to make 8, and those numbers happen to be 4 and 4. So therefore my other two factors are x plus 4 and x plus 4. And then since they're the same, I put them together as x plus 4 squared. And there is your final factored form. If you messed up at any point on this one, go back and check your work. Okay, you did synthetic division, then you turned it into a quadratic, then you factored that quadratic. Okay, we're finally getting to the really interesting ones, right? Solve each equation by finding all roots for 54 and 55. X to the fourth power here, there is no pattern that we know for x to the fourth power, okay? Factoring by grouping is not going to work. We have 5 terms. It's going to be a little bit complicated. So I'm going to go straight for synthetic division here, okay? I'm going to do one, you're going to do one, but this time I'll be nice. I will do 55 because I know you guys are scared of that number, 192 right there. And then I'll let you guys work on this one, which has the -15 in there. Okay, so let me work on 55. 54 is exactly the same sort of steps. Okay, just follow the steps as I do it on 55, and you should be able to handle 54. So watch, here we go. First, I'm going to set it up for synthetic division. Okay, so that means that I'm going to write 1, 4, 4. It's already in standard form, so I don't have to stress about that. 64 and -192. Well, running out of space there. Okay, and then I'm going to test out a bunch of different numbers. So I look at 192 and I really just have to come up with all the factors of 192. What goes into 192? Okay, so I got to come up with all of them. And it turns out that the factors are, okay, here we go. There's going to be a lot. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, yes, plus or minus 8 goes into it, plus or minus 12, plus or minus 16, yes, 16, I'm going to continue down here, plus or minus 24, plus or minus 32. Okay, there's no way we're going to get all the way to 32. Okay, and sometimes it will happen where you're going to try 1 and -1 and 2 and -2 and 3 and -3 and nothing works until you get way into those factors. But most of the time we're going to find factors that are pretty small. There's more. Plus or minus 48. I'm going to write them all even though I don't think we're going to get this far. Plus or minus 64. Plus or minus 96, and plus or minus 192. That's it. Yay, look at all these numbers that we get to test out. Not really. Remember, we're not going to test all of them. We're going to start at the bottom and work our way up, and hopefully we find one pretty quickly. Okay, so let's start with 1. Here we go. Bring down the 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. 4 and 5 make 9. 1 times 9 is 9. 64 and 9 makes 73. 1 times 73 is 73. -192 and 73 does not work, right? That's going to be -119. So no. Let's try -1 then. Let's see what we get. Bring down the 1. -1 times 1 is -1. -1 times 1 is 1. 4 plus 1, nope, -1. mistake right there. 4 minus 1 is 3. Negative 1 times 3 is negative 3. 4 minus 3 is 1. Negative 1 times 1 is negative 1. That's going to be 63. That's going to be negative 63. And once again, no, that doesn't work. Okay, so let's erase that one and try 2. And we've tried two numbers already. Hopefully we don't have to try that many before we find it. Okay, so let's try 2. Bring down the 1. 2 times 1 is 2. 4 and 2 makes 6. 2 times 6 is 12. 4 and 12 makes 16. 2 times 16 is 32. 64 and 32 make 96. 2 times 96 is 192. Yes, we did. We found it. We found the first one. We didn't find all of them, but we found the first one. Okay. So our first one is 2. I'm going to keep going right here where I am. Okay, so this right here is a quartic, right, degree 4. This is a cubic, degree 3. So I'm going to keep going from here until I get to a quadratic. So one more. Once I find one more, I'm set because I can work with the quadratic. Okay, so right here where I am, I'm going to keep going and try something else. The first thing I'm going to try is the same number again, just in case it repeats itself. Okay, so we're going to try 2 again, just in case it has a multiplicity. So let me erase this stuff right here. Hopefully we don't have to get all the way up to 96 and 12. So bring down the 1. 2 times 1 is 2. 6 and 2 make 8. 2 times 8 is 16. 16 and 16 make 32. 2 times 32 is going to be 64. 96 and 64 does not give me 0. So 2 does not work. Alright, let's try negative 2. Bring down the 1. Negative 2 times 1 is negative 2. 6 and negative 2 make 4. Negative 2 times 4 is negative 8. 16 minus 8 is 8. Negative 2 times 8 make negative 16. 96 minus 16 does not make 0. Okay. Moving on to 3. Bring down the 1. 3 times 1 is 3. 6 and 3 make 9. 3 times 9 is 27. 16 plus 27 is going to be 43. 3 times 43 is going to be 129. So no, that doesn't work either. Okay, try negative 3. And I know this can get frustrating because you try and you try and you try and you don't find it. But once you do find it, you can breathe easily and say, yes, I'm done. Okay, so at least we found one, right? We found 2. We found 1, 0, which is 2, is what I meant there. Okay, so let's keep going. Bring down the 1. Negative 3 times 1 is negative 3. 6 minus 3 is 3. Negative 3 times 3 is negative 9. 16 minus 9 is going to be 7. Negative 3 times 7 is negative 27. And that didn't work. Okay, next, 4. 1. Bring down the 1. 4 times 1 is 4. 6 and 4 makes 10. 4 times 10 is 40. 16 and 40 makes 56. 4 and 56 is going to make 224. So no, that's not going to work. So we try negative 4. Bring down the 1. Negative 4 times 1, negative 4. 6 minus 4 is 2. Negative 4 times 2, negative 8. 16 minus 8 is 8. Negative 4 times 8 is negative 32. And again, that does not work. So we try 6. Bring down the 1. 6 times 1 is 6. 6 and 6 makes 12. 6 times 12 is 72. 72 and 16 is 88. 6 times 88 is going to give me some huge number here that is not going to work because when I combine it with 96 it's not going to work. Alright, try negative 6. And right about this point is where you start to get really frustrated because we've been trying so many different numbers. Hopefully this one works. Here we go. Bring down the 1. Negative 6 times 1, negative 6, that's 0. Negative 6 times 0 makes 0. 16 and 0 makes 16. Negative 6 times 16 is negative 96. Yes, we see the light. We found it. That gives you 0. Whew. Okay. Now, we found 2 of them. This leftover right here is a quadratic. Okay, I'm going to turn it into a quadratic right away. That's x squared plus 0x plus 16, right? Equals 0. Solve that. I'm going to get x squared equals negative 16. Take the square root of both sides, and I'm going to get x equals plus or minus, the square root of 16 is 4, but notice that negative inside, it's going to be 4i. There's two solutions right there, and the other two are the ones that we just found already, which are positive 2 and negative 6. There's all of my zeros. That took a while. Okay, your turn. 54 is yours. Don't give up. Don't get frustrated. You will if you try a bunch of different numbers and nothing works. But the good news here is that the number here is 15, so it doesn't have that many factors, right? 1, 3, 5, and 15. That's it. You don't actually have that many numbers to test out. Okay, so go for it. Do exactly what I said. Test 1, test negative 1, test 3, test negative 3. Do it again. Do it twice, just like I did up here. Okay. Once you found the first one, don't stop. Find another one. And then you're going to take what's left over, turn it into a quadratic, and solve it in other methods, like the quadratic formula or factoring or something else. Okay, so there you go. Pause the video now and try it. Okay, so here you go. These are the four solutions: negative 3, positive 5, and plus or minus I, right? There's two solutions right there, remember? That's positive I and negative I. So actually, you didn't get to test out that many numbers. You tried 1 and negative 1, it didn't work. You tried 3 and it didn't work, but when you try negative 3, it does work, okay? And then you tried 3 again, and negative 3, it didn't work. So you went to 5 and it worked again. So negative 3 and 5 are the two that work that you got from synthetic division. And then what was left over was simply x squared plus 1, which gave you x equals plus or minus I. Alright, so we only have 4 problems left, but this video is getting extremely long, way longer than I expected. So I am going to let you guys work on 56, 57, 58, and 59 on your own. I am only going to get them all started, to basically give you guys the correct way of setting up your factors. But that said, you'll be in charge of finishing them up on your own. Okay, so here we go. 56, the correct factors that you should set up to multiply are x minus 1, x minus 4, and x plus 3. Do those multiplications and you'll have your polynomial. 57, x minus 1/2, x minus 5, and x plus 2. Multiply those out and you get your polynomial. For x minus 1/2, there is another way of writing it. You could also write it as 2x minus 1, which is the exact same, gives you the exact same 0, right? 2x minus 1, when you solve it, will give you positive 1/2. Okay, but either way, multiply them out and you'll have your polynomial. 58. These have imaginary and radical roots. So you first come up with the missing ones, the conjugates, which are negative 2i and negative radical 3. Therefore, your factors are x minus 2i, x plus 2i. I always put those two together. That's this one and this one. Okay. And then x minus radical 3, x plus radical 3. That's this one and this one. And the final one is x minus 4. And you're going to do a lot of multiplication there to come up with your final polynomial. Okay. And finally, 59. Once again, it's missing those factors. So radical 2, you also need negative radical 2. And negative 3i, you also need positive 3i. Therefore, your factors are x minus radical 2 and x plus radical 2. Put those together every time. X plus 3i and x minus 3i. And the final one is x plus 5, which is this one right here. Multiply all of those out and you will have your polynomial. Okay, so go ahead and pause it, finish them all 4 on your own, and then come back and I'll show you the correct solutions, and that'll be it. We'll be done with this. Okay, so here we go. These are the answers to the last four problems. 56 is x cubed minus 2x squared minus 11x plus 12. That shouldn't have given you that much trouble. 57, there's two possibilities depending on which one you used. Okay, so if you used x minus 1 half, you got this. X cubed minus 7 halves x squared minus 17 halves x plus 5. That actually is not the simplest one because we have fractions there. Okay, this might be the simplest one, in which case I use 2x minus 1 instead of x minus 1 half. Remember what I said? These two give you the exact same zero, so I can use them both. Yeah, so when I do this one and these two, I get 2x cubed minus 7x squared minus 17x plus 10. Okay, check your work. If you messed up somewhere, just look for where the little mistakes might happen, okay, because you're basically doing a lot of multiplication. All right, and here are the last ones. These were the real fun ones. 58, you got x to the fifth minus 4x to the fourth plus x cubed minus 4x squared minus 12x plus 48. When you do these multiplications, there should be no more terms with I or with radicals. They all cancel out when you do these steps, okay? So you should end up with this polynomial. No i's, no radicals. 59, same idea. After you do this multiplication, there should be no more i's, no more radicals. So x to the fifth plus 5x to the fourth plus 7x cubed plus 35x squared minus 18x minus 90. Okay, and that concludes the review. Finally, if you made it this far, if you've actually watched all of the problems, you want to truly be ready for the test, I'd suggest you watch it all over again and practice again. Okay, and if you did make it, congratulations. Okay, it takes a lot of effort to try to do this and work through all of the problems here. Okay, good luck on the test, and I'll see you guys in class.